We'll start now.
Okay, ma'am.
Anything you want to clarify from yesterday's session? No. Right. We'll start. It's 45. Okay, so in the value management, just to summarize what we discussed yesterday, it's defining value. And so how do we see the value, right? And then managing the value, it's a process, or it starts from the start, inception, and goes on up to the end of the life cycle. Okay. And within that, you find the initial step as value planning, and then value implementation, that is the value engineering, and then value analysis or value review, right? And that's the main thing that we discussed yesterday. And then how do we do this value engineering part? So that is through 4 different approaches. Okay. So one is Chariot, and other one is value engineering audit, and contractors change proposal, and specifically a 40-hour workshop is carried out to exercise this value engineering to a given project. Okay. Even in other methods, there is kind of a workshop, because as you can recall the definition of value engineering or value management, it's a facilitated approach, and it's a systematic. Also, it is a multidisciplinary in nature. So therefore, there are different professionals from different disciplines involved in a project. So it's a team effort. And so the team collectively, who are the stakeholders of the project, collectively involved in value engineering with the help of a facilitator. The facilitator can be an outsider. Even in the project team itself, you can have a few outsiders, external parties, depending on the requirements. So it's basically, why do you want to do value engineering, right? So depending on your purpose, depending on the nature of the project, you can hire people apart from the in-house, because it is always considered as an additional activity, right? So it's not just traditionally not just incorporated with the traditional activities in a construction project or in any sort of project. So that comes as an additional task, because a separate team is, so because of that, a separate team is appointed to look over the design to see whether there can be any value enhancement and any activity taken place to enhance the value. Okay. So often it is a special task. Of course, in time to come, it can come as a part of the traditional or the routine, what do you call this, project activities, we can say, right? So, yeah, depending on the nature of the project. So if you're talking about construction project, so we have the design stage, or even before the design stage, we have a planning stage. So even that stage itself, we can think of this value enhancement activities, right? Or else once the design is halfway through, we can see whether we can incorporate any value enhancement activities by giving a special focus to that, right? So, so to do that one, so we can actually have a part of the design team or the project team. Partly you can take people externally because who may have sometimes special expertise in this value enhancement activities with respect to, say, a different kind of project. For example, for a given project where the existing project team, they may not have expertise. So in that case, you can hire a expertise external, and also you have a facilitator, right? So therefore it's a special task. So that is approaches through various ways, right? So we look at these different approaches. We can go through the value engineering exercise for a given project. Okay. Yeah. So this chart is a particular approach. So started long time before, right? So in that, what happens is actually after the formulation of the brief, right? So the client brief, okay? So that's the one basically specify the client requirements, right? And also we appoint the design team, right? And appointment of the design team before commencing the actual design. Okay, so this particular approach or the exercise is carried out after the formulation of brief, right? So it's basically we appoint the team to study the brief in detail. Okay, under the guidance of a specialist, that is a value engineer or as a facilitator, right? For 2 days to raise questions and generate ideas, justifying the brief to improve the cost effectiveness. Okay. Value enhancement, all sort of value enhancement activities finally can be confined to cost effectiveness, right? So suppose if you go for a time consuming technical solution, right? So that is also ultimately result in some cost saving, right? Duration is reduced, so result in cost saving. So it's a cost effectiveness, right? So in this particular approach, that's what happening. So once the client comes out with his requirements in the form of a client's brief, with that, the appointment of design team is appointed and they study the brief in detail with the help of a facilitator, right? So the facilitator is going to facilitate the activity and ensure that the team, the design team, actively involved with value enhancement activities, okay? Or incorporate value enhancing activities within the design, okay? Because it's before the design starts, okay? So because once the design, as you have already seen yesterday in that diagram, even like design is completed or halfway through the design, we can incorporate whatever the value engineering aspects or approaches, right? Or value engineering proposals, but sometimes it may not be very feasible or very profitable. Why? As we have gone partway through the design, right? So therefore, it's earlier is the better because it gives the higher potential for value enhancement. Okay, increased potential than incorporating partway through the design. Okay. So therefore, before the design starts, here we appoint the team and let them to consider these various value engineering proposals and try to incorporate them during the designing stage. Okay, during design. Okay, so that is this chart. Okay, so ensures that designers fully understand client requirements, right? Attempts to rationalize the client's brief primarily, right? Because most of the time the cost effectiveness or the value for client is not met because of the reason that failure to understand the client requirements or the client brief, right? And so here, before the design is developed, so the team is appointed and let the team to study the brief carefully and ask any questions or any ideas we can propose to clients to make it clear for both the client as well as the professionals before they go further. Okay. So attempts to rationalize the client's brief primarily. So we make sure his requirements are rational. Okay, that can be achievable. Okay, so we come to that kind of a confirmation by doing this value engineering exercise. Okay, so that is basically this charities. Okay, because once the client requirements are carefully studied, most of the issues are resolved, right? Because a lot of variation comes and those variation result in or hinders the value of the project, right? Or yeah, prevent the value achievement in a project, right? So it's basically when there is a variation that is happening because of the lack of understanding about the client brief, then the variation anyway results in additional cost and time, right? So rather than that, if you can understand the client briefs carefully and question him for anything not clear, and also based on client brief, if we can advise him on the possible potential effect, he can also be prepared for that, and that way it will help to enhance the value of client's investment. Okay, right. So that is valid. It's just the 2 days. Why? So the design has not gone or not started. So it's just the client brief. So before we coming to proposals, the client brief is carefully studied and questioned for any unclear areas, right? So that way it helps to do a effective designing and subsequently effective construction and to ensure value for clients' investment. Okay, right. Yeah, that's about the chart. And the next one was used as an approach to value enhancement in projects were value engineering audit. Right? So in large companies, they do budgeting. Right? So we review and see whether the budgeting is appropriate. Okay. Expenditure proposals of large companies and government departments are reviewed by value engineers on behalf of clients. Okay. So the purpose is to make sure that the primary business functions, investments, and the cost reductions are in line with each other. Okay. So, yeah. So here also a normal job plan is adapted. Similar to that of a charity. So charity, it was a 2 days workshop, and here, of course, it can be 2 days workshop or it's a 40-hour workshop, 5 days workshop, right? So the normal job plan, we will look at the job plan a little later, right? So that is adapted in this value engineering audit approach. Okay. Then we have contractors change proposals. Okay. Yeah, so the contractor's change proposal is something often used in construction companies, contracting companies, large scale contractors companies. At least they do come up with this because they do not involve in the design. So once the design comes to their hand, then they come up with whatever the possible change proposal. And when they bring those proposal, they need to ensure that would result in some cost saving or time saving. Okay, so that those are accepted by the client. And suppose if it is accepted by the clients and whatever the cost or time saving reached, and that is shared between the contractor and the client. Okay, right. So the most common form of delivering value management to a construction project. Post-tender change initiated by the contractor. So contractor's change proposal means, so post-tender, that is often, we know that after the tender only contractor comes. So therefore, once they come up with any proposals, right? And permits contractors to be proactive, right? So at least before they do the physical construction, they tend to propose any solutions, and that would result in cost or time saving. Okay. And suppose due to their proposals, if a saving is made, then it is shared between the employer and the contractor. Okay. But on the other hand, there is a feeling or concern that this kind of proposal that the contractors bring in may cause delays, right? Contractor, they need to find out the merits and the viability of the proposed change. So they need a little bit of a time. So, but it's felt this would result in project duration extended. Okay, as they need additional time until they find the viability of the proposed project. Okay, that disadvantage is there. So that is anywhere there for any kind of project. Like, so that is the reason this is often like can be done parallelly by a separate team while they are working on the design, and the proposals can be designed
So the design can be evaluated, and whatever the additional thing that they come out with can be evaluated. Okay. So initial time even with the chart, so any proposals that can happen lead to delay, no, even at the design stage. So 2 days, but comparatively now this would take a little more time. Why? Here the design is done, whereas in the chart it is 2 days to discuss the client brief, and there is no design yet developed, right? So therefore, doing changes depending on the client's brief, right? Suppose if it is not clear, so clarifying that would not consume that much time, right? Whereas here its design is made, so if the contractor is bringing some proposal, so to introduce those proposal or implement those proposal, there may be some additional time cost. Okay. Okay, right. And the last one is the very formal approach, and it is called 40-hour workshop. Okay, very formal. Okay, so the moment it says value engineering application, it refers to this 40-hour workshop, right? Because depending on the nature of the project, there may be it's 40-hour needed to come up with, carry out the brainstorming sessions, and there are various professionals involving, and they are coming out with various views or various value engineering proposals, and those proposals need to be evaluated, and so it would require some time, right? Okay. Right. So the job plan, it consists of 3 stages. Pre-workshop. So we need to do some preparation for the workshop. And then once the workshop is done, we need to again document the outcome of the workshop and implement it, right? So that's happening during the post-workshop, right? And then we have the actual workshop that involves 6 different phases. Okay. So we'll get into each one of the phases detail to see what happens, who involved, and what they're doing, right? So, so this approach altogether called 40-hour workshop according to the traditional time scale, but shorter durations have gained more popularity in the industry, right? Even though it's decided at 40 hours, practically it may be less than 40 hours, right? Because taking 5 days off of your project means it's a huge time, right? So this value management process follows SAVE International Standard Value Engineering Job Plan, which consists of 6 phases under 3 main stages. You see this one? This is the yeah. So pre-workshop, it's pre-study activities, right? What do? before the workshop. Generally, if you have done any kind of workshop, so what is the activities we can do? What are the activities involved in pre-workshop? Yeah. Yes. You guys are there. Hmm? Yes. Pre-workshop activities. Huh? Haven't you done any workshop during your professional period? Practice? Hmm? Don't you?
I'm gathering information.
Yes, gathering information. Actually, during the workshop also, you can see there are different phases. One of the phases is information phase, right?
Yeah.
So that, of course, involve, yeah, there is not much of clear-cut difference between this pre-workshop. Some people do this collecting information, some other information during the pre-study workshop. And some during the workshop, the first activity will involve collection of some information
Yeah.
for us to carry out the workshop, right? Yeah.
Yes. And identifying project objectives and constraints, defining scope of workshop, like that.
Yeah. So yes, that also partly can be there or partly can be during the information phase. Yeah. So what is the purpose for which we're going to do the value engineering? Yes. Some logistic, like how many days we are going to do and where we are going to do and who are the parties going to involve, right? So those kind of activities we need to think before doing the workshop, isn't it? And then during the information, we collect the record information, right? About the project details. And so you can do a site visit and collect project details, right? What kind of project and who are involved and the required, the project data, right? Number of parties. Right? Maybe preparing a program for the workshop that can also come as part of the pre-study activities, right? Yeah. So pre-workshop, so that is the preparatory activities, and so a team is selected from a multidisciplinary expertise to obtain a large number of innovative ideas, right? So by looking at the purpose and looking at the project, we can decide who are the parties should be involved, right? So it's generally a multidisciplinary, and even the multidisciplinary, we may have some very specific disciplines, expertise required depending on the project, right? And so the team is usually consists of 5 to 9 members.
again, depending on the scope of the project, right? So led by a certified value specialist, CVS. Right, so certified value specialist, like, that similar to the professional institutes, there are value specialist institute of value engineering professionals, right? So they are from when you become the member and go through their activities, you can become a certified value specialist. And so along with this project team members, there is value specialist is involved. Yeah. Right. So project along with its scope of work is reviewed comprehensively and collectively. Yeah. So project along with the scope of work. So that is what we have to do, right? And comprehensively and collectively. Okay, so the team together study the project basically and understand the scope of the work. Okay, right. And also you can decide on the cost saving ratio to be achieved by the exercise, right? So that is something you need to decide, because it's a time consuming and also cost also there when you do this value engineering. Not very expensive, but still, a separate team is engaged and totally separate, or else along with the one or two parties from the project in-house. So this particular special team is working on a special task, right? So therefore, we need to actually have a outcome for that. Otherwise, it's not worth, say, if you let rather than that, if you just leave the in-house project team to think of whatever the possible value engineering proposal, they would reach some saving, right? So now this is a special task, special team is engaged. So therefore there should be an outcome decided in advance, right? So therefore cost saving ratios to be achieved by the exercise are determined by carrying out an initial cost study. Okay. Then a timetable is prepared stating the beginning and the end of each stage of the study. Okay. Okay. So that is the basic fact. Ensure that all parties are well coordinated. Then activities to be considered in pre-study, orientation meeting. So they get together, and the team structure, members, right? And workshop duration, site visit, cost estimate, models. These are some of the things we can come up with during the pre-workshop, right? So, yeah, site visit also, so that we can understand the scope of the work, right? Or the nature of the project, right? So if we can have that basic understanding, it may be easy for us to come up with for the team to come up with the feasible solutions, right? So creative ideas, and thereby reach the feasible solution. So they can do some cost estimate, initial cost estimate, then they can establish
the cost saving ratio, right? So this is the originally, right? So if you don't apply the value engineering, the cost is this much, right? So then through the activity, how much you want to reach. Right? So that kind of, so therefore there could be initial cost estimate and models we can come up with, right? So in the model, we can do changes and see the effect of value engineering proposal. So therefore, whatever required to carry out an effective value engineering exercise can be set up at this pre-workshop stage. Okay. Right. So in identifying the people, whom should you have in the team, right? And often you can use a basis to choose the parties as based on these three. One is who own the problem, right? Client also you should have in the team, right? Or other stakeholders who will have the problem, who will face the problem, okay? And then impacted by the problem. So that is the external stakeholders, somebody representing that can be part of the team, right? So that will then again would ease the decision or the solution, right? Because some of the technical solutions that are proposed may have some impact on some people, right? So therefore, better to incorporate the people who can be impacted by the problem. Okay. Yeah. And the support function, right? And others who can perform the functional support, right? Who provides functional support, right? That is, we can say the professionals, right? So they do support for the functional performance of the project or building, right? So therefore you can have them as part of it, and also other parties who is affected by the problem. Okay. That is a kind of a basis for you to choose the project team or the value engineering team, right? Okay. Then we go to the actual workshop where there are 6 different phases or stages. Okay. Information phase, communication, functional, information and functional phase, and then creativity phase, then evaluation, development, and finally reporting and recommendation, right? So information phase, you collect all the required information to carry out functional analysis. Okay. So next phase, we carry out the functional analysis, right? So the value engineering, it's the involve enhancing the functional value of a system or project or building or whatever, right? So therefore, in order to enhance the functional value of a project or system or anything, so we need to involve, right, right? And okay, then once we have done the functional analysis, next is creative phase. Say we come up with the outcome in the functional analysis. There are certain functions which can be improved or certain function which can be removed and so on, right? So therefore, for those which we can remove or improve, we have to see whether we can come up with any creative solution, right? And there can be number of solutions we can come up with, and those solutions we need to evaluate. There will be number of solutions and we need to evaluate them on a kind of a superficial level, right? So we can't do a detailed evaluation of all the solutions. So if you have come out with thousands of solutions, we can't do an evaluation for all thousands, right? Detailed evaluation for all thousands, right? So we do a kind of a superficial evaluation that takes place during the evaluation phase, right? And then we move to the next phase, which is the development phase. In that, of course, for the selected in the evaluation phase, we do the superficial evaluation. So a surface level or a kind of a broader level evaluation. And based on that, we can choose few options as most feasible. And for those options, we can go for detailed evaluation. So that happens during the development phase. So we do the further development, or detailed, in-depth evaluation of the selected few solutions. Okay. And then of them, we come up with the recommended solution or solutions. Okay. So and those are reported and recommended for implementation. Okay. So that is the entire the value management process. Right. So we'll look at in detail one by one. Information phase. Right. So information phase, to get value management team to fully understand the major aspects or nature of the project. Okay, so this can take place during information pre-workshop or else during the information phase, right? So you collect all information so that you understand the project here, right? And then presentation. So you can have okay. So for this, we can use presentation, that is architectural presentation, cost, services integrations, like that various presentation. So that gives us an understanding of the project. Okay. And then with that information, we proceed for the functional analysis, right? So each and every function in detail is analyzed, right? For any possible improvement of the functional performance by get rid of unwanted functions, right? So how do we analyze functions of a system or item, usually by a verb and a noun. So that is an easy way to understand the various functions associated with a system. Okay. Right. So see, there are a few verbs: amplify, change, control, create, enclose, etc. And door, we say control the cases. Control the access, sorry. And cable. So we have cables in a project, and that is basically to conduct current. Right? So conduct is verb and current is noun. Right? So every function is analyzed like this, identified like this. Right? Why this is there. Right? Whether this can be done by anything else. So you can ask those two questions. Why and how else this can be done? Is there any other alternative way? Right? And so we consider alternatives and evaluate and see whether those alternatives are resulting enhanced performance, but at a lesser cost. Right? So then only it becomes cost effective, right? So you remember the value management definition, right? Reducing the cost while maintaining the performance at the same level or by improved performance, right? So both could happen. So either maintain the performance at the required level and reduce the cost, or reduce the cost with increased performance. That is far better than maintaining the performance at the same level, isn't it? Right? So that is one thing. So therefore, each and every functions are studied carefully, identified and studied carefully. So identified by asking the question, why this is there, right? So if there is a door and you see whether this door is required, whether it can be replaced, it can be removed. Why? By removing it, you're going to have some cost saving, isn't it? And also, obviously, construction will be, time will be saved, obviously. And but what happens to the functional performance if the door is removed? Any impact to that? There may be ventilation issue, or there may be privacy issue. So those are, if those arises by removing the door, mean you should not do that, right? So it's important functional performance is maintained at the same level with the reduced cost. Okay, so that is what we call it as value enhancement. Okay, so look at the system or a project or a building project or whatever project and carefully study the project. That is what an extra team, a special team is assigned to carry out the special task and come up with the technical solution that result in enhancing the value of the project. Okay. So from the A to Z, study the functions of a given project. Okay. All right. All right. Is that clear, the functional analysis as to what is happening there or what should happen there? Yes. All right. No response. Are you?
Um,
I tend to sleep and because of your responses. None of you are responding also. That class is very dull. If it is physical, of course, I can see your faces and I can point out you to some of you and ask some, and I can generate some discussion. So make it interactive. But here it's hard, but when you don't respond also, I tend to fall asleep. Huh? Isn't it? You should make it interactive. You people are not only doing this work now, maybe on the other side, you may be doing something else. Eh? Office work is also there. Eh? No? See, nobody is responding. Okay. Anyway, right. So we have to, again, to understand and in detail about the functions of a system or project or whatever. So we can easily classify the functions as primary, secondary, required secondary, and so on. Right? By doing that one, again, it's easy for us to understand the functions, right? So basic functions or the primary function, of course, we can't do anything with that. Secondary, of course, we can get rid of those secondary functions if required. And if it results in some improvement to the value, the functional value, we can do so. And also it would result in some cost saving, we can do, right? Because it's a secondary function. So we can do something. Basically get rid of it, right? But you see, there are some functions, some of the secondary functions are required in order for the primary function, right? So to fulfill the primary function, there are some of the secondary functions, they are essential. Without those secondary functions, we can't achieve the primary functions of a system, right? So if when you classify it, you can understand, right? So we keep the required secondary function and we try to remove the secondary function. And by removing so, we have to ensure that nothing is harmed for the primary function. And on the other hand, the effectiveness of the primary function is high, and also that result in some cost saving, cost reduction, right? So we need to ensure that, right? So every design has basic and secondary function. So impossible to seek alternatives to a technical solution without identifying the functional definitions. Okay, so the functional definition, whether it's a basic function or a secondary function or required secondary function. So we need to classify that, identify that. Okay, light is required in a room, that is functional definition. Okay, so why it is there? That is the question. So ask that. Go into the design and see, ask that why it is there, each and every, right? And to install a component which emits light is a technical solution. Okay. Okay. So again, what is basic function? Principal reason for the product's existence, right? So that is the primary function, no? Why that particular product is there. So that is the primary function. Okay. and it has a value to the customer, right? So primary function. And loss of basic function result in total loss of the market value. That way you can identify what are the basic functions. Okay, or what is the basic function? Maybe performance or esteemed base, right? So because those are essential, right? And if those primary functions are not there, there is no value for that, right? And then how do we identify the secondary function that is assist in or necessary for realization of a basic function? That is what we call it a secondary function, no? And so this is the one we actually target for reducing. Either we can modify whatever the secondary function, or else entirely we can eliminate it. If by doing so, if we can reduce cost or reduce design complexity, achieve breakthrough in design, we will go ahead and do, right? So that is the purpose of the outcome of the functional analysis. Okay, so whether we can get rid of any of the secondary function, or else we can modify the secondary function that result in reduced cost or reduce design complexity, and or also by removing that unwanted function or the secondary function will make a breakthrough in design, right? People traditionally keep designing, but here you give us special thoughts over the design and see whether there is any possibility for improving the design by doing some value engineering applications, right? So that would result in design optimization as well, value engineering. Why? So here trying to do a detailed functional analysis, and from that, anything which doesn't add value to the system, we are going to remove. And by not having that component or that subsystem in a system, we might have some cost saving. Next time when you produce, you don't have that element anymore. And that gives some cost saving. So when you produce in bulk, so there is a huge saving, right? And that doesn't impact the performance or the aesthetic appearance of the system. There is no impact. So we'll go ahead and do that one. So that is the outcome of the value management. Okay. Right. So there is electric lamp, so which satisfies the primary function of a okay. So lamp which satisfies the primary functions of emitting light. Unwanted secondary function in the electric lamp, generating heat, inducing glare, and looking unattractive. So resolved by further technical solution. Okay. First areas to examine for saving is elements that perform secondary functions, can be reduced or deleted entirely without affecting the basic function of the component. Okay, is that clear as to what we are going to do? Okay.
Okay, ma'am.
Okay. Right. Sorry about it. Right. So that's what happens in the functional phase. Okay. We move to the next phase, or we can have some examples of understanding the functional phase. Look at this simple example. If you are doing a value engineering for a pencil, this is the way we analyze the functions of from top to bottom, each and every element. What is its purpose? What does it do? Okay. So then classify whether it's a primary function, essential, primary none. It's anyway essential, but if it is a secondary function, you ask the question whether it is essential. So some of the secondary functions, only one function, it's for the writing, right? But some of the secondary essential, by painting, protect wood, improve appearance, display information, deliver message. So those things, secondary, if necessary, we can eliminate, isn't it? Band, secure eraser, and to improve appearance, right? Without the band, if the band contribution to the cost, because when you do it in large quantities, there is impact. You might be wondering, like, it's a small thing, how much of saving we are going to have? But these are bulk production, and there may be a lot of saving, right? Okay. Yeah. Uh-huh. That's for the dean's office name. What about our side? Oh, and also we can see meantime whether Sumanadasa building will have the power, ne? If it has, we don't. Okay, okay. Yeah, yeah. Yes. Yes. Yeah. Yeah. That is anyway internal. We need not to talk about that. Yeah. Okay. Better. Yes, hope it's clear. So this is a way we go into the possible detail and analyze. Because when you do it at a broader level, we may not be able to understand its exact function and see whether that can be something necessary to improve or eliminate, right? So that is we do go to the possible level of segregation of the functions, right? Pencil, if we keep it as it is, it's just one function, you will say it's for the writing purpose, right? But when you break into elements like this, you can very easily see the functions of each and every small element of that entire product, no? So we have to do it that way. So breakdown of functional, this is called the functional breakdown. So functional hierarchy, right? So you just see here, yeah. You say for the buildings, so typical subdivisions of functions provide accommodation, right? So just one function, and then that support building, and then we have foundation, slab, drainage, right? And that they are further divided as provide envelope, divide space, finish surfaces, right? And then that also we can divide further as frame, external walls, windows, external doors, and so on, right? So this is called actually functional hierarchy, okay? Right, so in the functional analysis, we would consider, right, so the value, it's defined as enhancing the functional value or the performance of functions in relation to the cost, right? So therefore, value enhancement means either the functional performance remain constant while maintaining the functional performance constant. If we reduce the cost, there is value enhancement. Or meantime, increasing the functional performance, we keep the cost constant, the second formula. The third formula, improving the functional performance while reducing the cost. The result is value enhancement, okay? And improving the functional performance twice while increasing the cost once. That is also, we can see value enhancement, right? And the final formula, functional performance reduces, but the cost reduction is twice the functional performance reduction, right? So mathematically, that also we can say as value enhancement. Why? The net effect is still saving, isn't it? Right? So this is the way we can see the value enhancement. Okay, these are some of the different ways we can define the value enhancement. Okay, so to analyze this functions of a system or product or whatever, we use functional analysis system technique, right? FAST diagram it's called. Okay, so that gives a systematic way of analyzing the functions in a system, okay, or a project or a product or anything, right? So hierarchy of functions by how, why approach, right? As I said earlier, when you look at the system or look at the project, right, go for the possible segregations of functions and at different level, hierarchy, broader level, divide the functions, further go down each and every function, see whether you can subdivide it and go to the next level that can be further subdivided, right? So as you can see from that pencil example,
go to the possible level and see each and every sub functions, right? So then start asking from the bottom, why this function is there, right? Or what does it do? What does this element do? Whether that function can be performed by any other element in the system. Okay, so if so, we can remove this, isn't it? Right? So what does it do and how else this can be achieved? Breaks the overall problem into individual and readily manageable components. And so that permits a balanced analysis at different levels, right? Every level go for the possible segregation of functions. Resembles a decision tree with answering for why from right to left and how from left to right. Okay. Ask why and how and get the answer. Decide whether to keep or improve or entirely eliminate. Okay. Right. How, why. Divide. Right. So why do I design a shopping center, construct shopping center? How do I design? First, I assess the requirements. What do I assess requirements to design shopping center? Why do I establish program to assess requirements, right? Why and how. Can you see this chain? How do I construct? First, I design. How do I design? First, I assess the requirement. How do I assess the requirement? First, I establish the program, right? How? Okay, so this is fast diagram. And here you see for the pencil, keep records, maintain information. And if you take record information, make marks, deposit medium, apply pressure, and okay. First diagram and that and that. Okay, so after the functional analysis, what is the outcome? So what function we're going to keep, improve, and what function we're going to eliminate. Okay, and for which improving functional performance. List out those. And for those functional functions, we come up with technical solutions. That is creative ideas through innovative thinking and brainstorming. Okay, so ideas will be generated by the value engineering team. Now they collectively do the brainstorming and come up with creative ideas. Okay. And after reviewing the functions. Okay. So to generate large quantity of ideas for alternative methods to perform each function chosen for further study. Okay. So large quantity of ideas for alternative methods to perform each function chosen for further study. So at the functional analysis phase, you choose the functions, right? And for which we are going to further study. Means we are going to enhance the value of those functions. That is the list you come up with, right? And for those, you come up with ideas, alternative methods, how else those functions can be performed. That is the question. What functions that you identify? Okay. So that is creative phase, nothing much in the creative phase. It's basically coming up with a large quantity of creative ideas. That's it. And then evaluation phase. Evaluation phases, we got to evaluate all these ideas we generated in the creative phase by the value engineering team, and they're going to evaluate it. Okay. The ideas generated during the creative stage are sorted into a list of feasible, low cost or energy saving alternatives. Right? So we sort them. Right? Right. So advantages, disadvantages of each idea are listed and discussed, and the ideas are ranked in order of viability. Okay. Now we just consider some surface level evaluation. So consider the advantages and disadvantages. Professionals of different discipline, they're going to give the advantages and disadvantages. They are collectively discussing, and based on these advantages and disadvantages, we do the evaluation and list, rank. What is the most feasible one? Next feasible, and least feasible, like that. Selected viable ideas are then evaluated in detail, and capital and life cycle cost are estimated. Okay. So for those selected viable ideas, we need to do detailed evaluation based on its initial and the life cycle cost, right? So here we evaluate using some techniques, right? Alternatives are further subjected to weighted evaluation, that is consideration of aesthetic, reliability, flexibility, etc. Okay. What are the techniques we use? Criteria scoring, feasibility ranking, idea comparison. So these are some of the common techniques which are used to evaluate the selected ideas, right? For that, not all ideas, right? So criteria scoring metrics. Look at this. So alternatives, right? So A, B, C, D up to G, there are options. So those are criteria actually. And the options are here, you see. First two options are listed like original, that is the original design in the original design, what is proposed. And then we have a alternative, 4 passenger elevators including 1S5, 4 passenger and 2 freight elevators. So that is the original design. Okay, now there are 2 alternatives, and those alternatives are evaluated in terms of various criteria. What are the common criteria? Initial cost, aesthetic, maintenance. Right. So initial cost, we first evaluate the criteria, comparative evaluation of criteria and alternatives. So in terms of what are the most preferred criteria, right, for the client. And so for that, you can see that preference given. So each criteria, how it is important. Some clients are very much concerned about cost. Some clients are very much concerned about aesthetic. Some are not about initial cost and aesthetic, but they are more concerned about maintenance. Right. Some clients are concerned about all. Right. So based on their preference, we evaluate, right? And for that, we'll use a scale, right? So you look at that scale, 4-point scale, where 1 is letter or no preference. Each scored 1 point, right? So for that client, basically all are equal, equally important, right? Initial cost, aesthetic, maintenance. Suppose if all are equally important, we will give score 1. Suppose one is minor preference than other one, that is represented by number 2. And one is medium preference to other, it is represented by 3, right? Right. So what does the A3 represent? Initial cost has the medium preference over aesthetic. Medium preference is represented by 3, number 3, right? So A3 means it's given to A. So A is medium preferred than B. So A received 3. And there is a A2. What does it mean? Compared to each scoring is criteria. Each criteria is compared with all the other criteria, right? So take the initial cost, compare with the aesthetic, and accordingly, it says initial cost is
medium preferred to cost. And when you compare the initial cost with the maintenance, it is minor preference. So that A is A2. A receives 2. And there is a C3. 3 is for medium preference. C3 means maintenance is medium preferred over aesthetic. Why? That C3 is representing the comparison of C and B. Okay. So the first, the edge, can you see this? This edge, you compare the every other criteria with the initial cost, right? Suppose, say we compare the D as durability. Let's say D is criteria of durability, right? Or usage, right? Suppose if we take that as that, and if I say the initial cost have, or if I say the durability is medium preferred. Okay. Suppose I say durability is one criteria, and I say the durability is medium preferred to initial cost. Where will you put that? Durability D, and it is medium preferred to initial cost. Medium preferred is represented by 3. So D3, where do you put the D3? Maintenance. So you put here, right? Comparing the D with the C. Okay. Is that clear? How do you construct the scoring matrix?
Yes, ma'am.
Okay. Right. And then for each and every criteria, you add the scoring, total score. For A, as per what is indicated in the diagram, A receives 5 and C receives 3 and B will assume 0. Right? And then that weightage is adjusted for a scale of 1 to 10. Right? Accordingly, first one becomes 10. Then the second one become 1. And third becomes 6. Right? And then according to the other scale, alternatives are compared in terms of using another scale, right? And say the first one, original 4 passenger and 2 freight elevators, right? That is in terms of the initial cost, that is poor. And in terms of the aesthetic, that is poor. And in terms of the maintenance, it's excellent. So you see 5, 1, 1, the diagonal, below the diagonal line, you get 5, 1, 1, right? So that is for each of the criteria, that particular system is considered for each of the alternatives, right? So 5, 1, 1, and then that one, this one, can you see the cursor, mouse point?
Yes, ma'am.
Okay, so this one is multiplied by the 10 on top, and you put that on the top of these diagonal line. Okay, and here also, so 4 and then 2. So okay, and then you can see the first one the same way we do it for the first one and the second option as well. So the first option receives the total score of 30 plus 1 plus 10, 41. Similarly, the second one receives the score of 12 plus 4 plus 50, so 66, right? And then we choose out of these two options the second one, that is the alternative, that is the highest total is preferred option. Okay. Okay. So now for this second one, it is better than first one as per this evaluation phase analysis, right? And for that, we will do a detailed evaluation for the second one. So that happens in the development phase, right? If you want, you can see this example as well. If you want more understanding about the how does this evaluation metrics works. Hello. Yeah. Is that clear? The decision matrix? Right. So here there are 5 criteria. Okay. Initial cost, maintenance cost, aesthetic, privacy, durability. Okay. And there are 4 options: aluminium, bricks, timber, glass blocks. Right. And so first of all, we do a comparative evaluation of these criteria. So whether any preference over any other criteria, right? So so look at this one: initial cost that needs to be compared with all the other 4 criteria. So when you compare the initial cost with the maintenance cost, you get the scoring on this line. Okay. Then when you compare the maintenance cost with all the other 3 criteria, the scoring will be here, right? Aesthetic comparing with 2, so the score is here. And similarly, privacy is doing, it's compared with the durability, and there is 1. Okay. Now at the score for the criteria, first criteria, that is initial cost. Initial cost has received a score of 14. Maintenance has received a score of 4. Why? Here B and D are equal. So 1, 1, 2, 4. And criteria C has received only 1 score marks. And criteria D has received, so here 1, 1 and here 1, 3. Okay. And so then we go for another ranking here, 1 to 10 ranking. And then we multiply this. Each options are ranked for this criteria against this criteria. And so this 10 multiplied by 3, you get 30. 3 multiplied by 2, you get 6 at the bottom of the diagonal line. And similarly that. And then when you add the bottoms, so it gives 54 totals for when you add this one. So 59, 50, and 42. So amongst the all 4 alternatives, bricks receive the highest score. So that is considered as the best alternative. Okay, right. So for that, we have to do the detailed cost analysis and see how much what happened. Okay. So for the brick, we do a detailed assessment and see how much it costs. Okay. That's what happened in the development phase. Evaluation phase, detailed assessment of possible alternatives, remove the ideas which are not fulfilling the primary function and not satisfy the client requirements. Impractical, further technological assistance required. Okay. Identify disadvantages, advantages, and rank the alternative based on the decision-making metrics. Okay. And you see here, there are 2 options, not 2 options, 5 options. An analysis of concrete alternatives for a underground railway project. Okay. And those alternative concretes are evaluated against 6 different criteria: workability, durability, beauty, ecology, economy, safety. Okay. Okay. So this is the surface evaluation, superficial evaluation, right? Get the scoring. And you see here, the original design, that is the traditional concrete, that 107, whereas this second one, SCC concrete, that is low weight concrete, low weight aggregate concrete, or some different alternatives. And that receives 68 score only. This received 129. So therefore, we are going to compare the cost of SCC concrete with the cost of traditional concrete. Okay. Okay, so final stage is reporting. So why costing? Where is the costing? Yeah. Yeah, so after this, so in the development phase, further development. So we do a very in-depth evaluation, right? So how do we do that? Either using the life cycle cost techniques or cost benefit analysis or investment appraisal technique or risk analysis, right? Okay. So here, right. So consider the original budget plan using traditional concrete. So how much the quantity? 56,900 meter cube of concrete is required. And for that, they do a breakdown, right? So pre-mixed
high pressure pumped motors that cost about 182. And then technicians, 6.8 million. Unskilled workers, 98 million. Okay. Unskilled pumps and tool wear. So this all you need to work out in detail. We can't do this detail for all the options. So therefore, first few we will do a detailed evaluation that happens in the development phase, right? So it comes to 352 million something. And see the alternative budget plan using SCC concrete. That's the same quantity. So premix high pressure pumped motors, 184 million. Technician, 4.5 million. Unskilled, this. So adding that. So total is coming around 265. Previous one is 352. So there is a saving. Okay. Is that clear? So each of the phase, what is happened? Functional phase, very detailed functional analysis. Outcome is remove whatever functions which are not essential. Secondary, but also not required for the essential function. Performance of the essential function. Okay. Last is reporting. And so there are benefits actually. Project cost is there. Value management cost is from the studies. It said like it's just 1% of the total cost. 99% goes to project cost. And so if you apply, whereas if you apply, there'll be cost reduction of 10%, right? Right. Any questions? Any question? Is that clear, the theory part?
Yes, ma'am.
Others? Only you are responding. What about others? Are you all there? Hmm? Yes. Any question? Yeah. You don't ask any question, but in the exam performance is very poor. I'm so disappointed with you guys. I don't know what to do. Hmm? Yeah, I'll share one or two case studies where, and it's similar like entire value management exercise findings. So we'll take a break, short break, and then we'll look at that. Okay.
Is that okay?
Okay, ma'am.
And share. shall we start? Resume? You are there?
Okay, madam.
Yes, ma'am.
Okay. Right. So, share two simple case studies, not construction, but a different product application for a product. Okay. So, this is one case study. And so, this is the definition, just to refresh you. It's an organized, systematic approach directed at analyzing the functions of systems, equipment, facilities, services, and supplies for the purpose of achieving their essential functions at the lowest life cycle cost, consistent with required performance, reliability, quality, and safety. Okay. So that's a very simple definition. Essential function. So we are going to keep the essential functions and at the lowest life cycle cost. Remember, it's not just the initial cost, the entire cost, okay, throughout its lifetime. Oh, yeah, life. Okay. And consistent with required performance. That is also important. So not that sacrificing the reliability or quality if you are trying to achieve the lowest life cycle cost. That's not the purpose of value engineering. Okay. Right. So it's an organized, systematic approach. Right. You will see how systematically we consider this application, right? And a system where we systematically take the this exercise through the system, okay, selected system or a equipment or process or whatever it is, okay, right. So a systematic approach to analyzing functional requirements of products or services for the purposes of achieving the essential functions at the lowest total cost. Okay, very simple definition. In the theory, I showed you various definitions proposed by various authors, but if you can remember just one covering the all key terms, that's enough, right? So in that way, it's a very simple one. So you shouldn't forget it's an systematic approach, right? Analyzing the functions, very important. We're analyzing the functions and also purpose of achieving the essential function at the lowest life cycle cost, consistent with required performance, reliability, quality, and safety, etc. Right? So whatever, because certain systems, or depending on where we apply, right? For anything, performance is there, reliability is there, equipment or system or facilities or services, whatever, the reliability should be there and the quality should be there. So then when dealing with, there should be safety as well, right? So therefore, by taking into all these aspects, if we can provide the system with the lowest total life cycle cost, that is the essential function of a value engineering. Okay. Right. So here, so it's not just good engineering, not a suggestion program or not a routine project or a plan review, not typical cost reduction, in that it doesn't cheapen the product or a service, nor does it cut corners, right? So it's not, many people say it's a cost cutting exercise the moment we ask what is value management. So hereinafter, you shouldn't say that. It's a cost cutting exercise, reducing the total life cycle cost subject to maintaining the performance at the required level. That's very, very important, right? Or improving the value of essential functions while reducing the total life cycle cost, maintaining the required performance. Okay, if you can say that way, that's fine. Simply answers the question, what else will accomplish the purpose of the product or service or process we are studying? Okay, that's another way of looking at. Look at this kind of a microscope used, and it's a kind of
a medical instrument, right? So we use in the labs, right? Medical labs, right? So it's a manufacturing process. It involves various elements, right? And there is a feeling that cost of that is high, right? So in order to reduce the cost, and this value engineering exercises or activity is carried out by analyzing its elements and their functions carefully, systematically, right? Whether there is any improvement can be done to the functional performance, or else now the performance, if it is all right, there is no complaint about it or complaint about it, we can maintain at the same level, but there is a concern that the cost of it is high. Okay. So therefore, in order to reduce the cost, we trying to do this, apply the value engineering, right? So company which produces different types of microscopes and export to various countries around the globe. One of their model is a particular model which has the application in the field of eye inspection and have a component named the focus adjustment knob. You see there is one. So two types, coarse adjustment and the fine, small one and the bigger one, right? Fine adjustment knob, right? And so value engineering application to the focus adjustment knob, right? And so if you look at just that simple product, because this is an assembly oriented, and so we take various product from manufactured separately and assembled, right? So in this particular microscope, we are looking at only the adjustment knob, right? And so for that, the cost of that is felt as high. Okay. Right. So in doing that, so we need to approach this particular product systematically, right? Product selection plan, right? So this particular knob is made out of various products, right? And gather information of product. And then we do the functional analysis, creativity worksheet we prepared, evaluation, and then finally do the detailed cost analysis, and we come up with the result. Here the steps are different compared to that same, like different in the sense different terms are used, but the work that you're doing is same. Functional analysis we have to do, and information of the product we need to collect. Also, we have to come up with the creative ideas, and those creative ideas are entered and in the order of its preference, and then we do a evaluation for the some of the creative ideas, and then amongst we come up with one or two, and for that we'll do the detailed cost analysis, and then we'll be recommending, that is the results. Okay, it's the same workshop phases. Okay, right. So product plan for the product selection, right? And focus adjustment knob or slit lamp in microscope used to adjust the focus of lens for magnification purpose. Okay, the present specification of this part and its material used are costlier than the average industry cost. Okay, so value of this product can be increased by maintaining its functions and reducing its cost, or keeping the cost constant and increasing the functionality of the product, right? So you can do both. Maintaining its function and reducing its cost. That's one way. Or else keeping the cost constant, increasing the functionality of the product. Okay. So that also will convince the users, right? So cost is same, but for that cost, we are trying to give more functions. So people would like it. Okay. Right. And product information. So this is the material used is aluminium bronze alloy, diameter 30, thickness, cost, pieces produced annually, process used, cycle time, anodizing, material costs, blah, blah. So these are all information, possible information related to the given product. Okay. So annually 8,000 pieces are produced, right? So even if there is a small saving in one element, there is a huge saving to the industry. Okay. So total present cost is almost 30 per piece. Okay. Right. So functional analysis. So we look at focus adjustment knob, basic function, index, noun is there is lens, right? And the secondary function, it fix the gear tooth. Okay. And whether we can do anything with the secondary function. Okay. And develop alternate design or methods. During the brainstorming, these ideas were listed. Change design, change material, use plastic, make it lighter, change the production process, use nylon indexing unit. Okay, so these are some of the ideas that were generated during the brainstorming. Okay. And so from this, we can shortlist the ideas and go for the evaluation phase, right? So in the evaluation phase, as we seen with the previous example, so there are different criteria: function, cost, maintainability, quality, space. We can evaluate in terms of these 5 criteria, right? So each of these design criteria was given a weightage factor. Each of the above criteria was compared with others, and depending on their relative importance, 3 categories were formed: major, medium, minor. Right? A score of 3, 2, 1 was given, right? So you can see major difference 3, medium 2, minor 1, right? And we can do pairwise comparison. So each of the So each of these criteria are compared among them, right? So A, B, C, D, right? So A, function, cost, maintainability, quality, space, right? So when you compare the A with the cost, it's B2, means cost is medium preferred, okay? And then A compared with maintainability, it's A2, means function is medium difference. Wait. Yeah, so it's actually relative importance. So why did I put as difference, right? So it is relative preference, okay? So it's medium preferred. So medium preferred, function is medium preferred compared to maintainability. So it's A2. Again, A is compared with D, that is quality, it's A1, means minor preference, right? that is also function is minor preferred than quality, right? So like that, next time we compare the second criteria, that is cost, with all other three criteria, right? And then we compare the maintainability, the third criteria, with the remaining two criteria. Then D, quality, is compared with the remaining one, that is space, right? So that gives this total score, right? So then you can see this, the score for each of these, right? Okay, so cost has received high score, then function, quality, maintainability. For space, of course, not of preferred one, right? And then with this score, we go for alternatives, right? So discuss, and the best feasible ideas were separated as, out of how many we had, number of, there was 6, right? So out of the 6, 3 has been chosen for further evaluation, right? Change the material to steel, use nylon unit, use existing material. These are the 3 were considered, right? And these 3 ideas, we can assess them based on these 5 criteria. Okay, so that 5 criteria score as 68250. Okay, and then when we consider this alternative, and for first alternative, the first criteria A is taking the scale of 1. For the first, the second is taking the scale of 2. Third criteria C, maintainability, that is taking the scale of 1, and so on, right? And then when you multiply 1 into 6, 6, 2 into 8, 16, 1 into 2, 2, 1 into 5, 5, and so on, right? So it is total, you can add 16 plus 6, 22, 2, 24, 5, 29. Okay, this total score is 29. And similarly, for all the 3 ideas or alternatives, they are evaluated against the 6 criteria. Okay, and accordingly, the second option, the second alternative, that has received the highest score of 48. So received the first rank. What is the second? Use nylon unit. Okay, so that is the most preferred alternative idea considered as per the first surface level evaluation, right? And then for that, we do a detailed cost analysis. Okay, at current, as per the material cost, 19.04, machine cost 7.3, anodizing cost, and thereby the total cost come to 29.9. Now they are going to change it to nylon indexing unit, so that the material cost is reducing to 11.6 and the machine cost is reducing to 6.80, and there is no anodizing cost, so that the total cost comes down to 18.4. Okay, so you can see how much of reduction from 29.99 to 18.4. Okay, so that is per unit cost saving. So 8,000 we produce annually, so there will be a saving of, per product is 11.59, so which is a percentage of 39%, and annual demand is 8,000, so that annual saving is 8,000 into 11.59, 92,720. So value improvement of the product is 62, the cost saving is 38.64, and that is 62% value improvement. Okay. Right. So this is a simple example for you to understand how does that value engineering works. Okay. So it was applied to increase the value of the product by substituting another material in place of the one that is currently in use. Various advantages have been observed in terms of cost reduction, increase in overall production, reduction in manpower, and reduction in scrap. Okay. So all the benefits. In future, alter the design of the product and integrate this technique with various other prevailing industrial engineering tools, which will bring down the cost by a substantial margin and thereby increasing the value of the product. Okay. So this is one example. And there is another example also you can see. Right. So value engineering is applied to a bath fitting product. That's flush valve. Okay. So the steps followed. Functional analysis worksheet is prepared for different parts of the product, right? Because you need to segregate the product as much as possible for you to easily understand its functions, and also comparatively you can evaluate the functions and see what are the essential functions and what are the secondary functions, and see whether we can do any improvement to the secondary function that helps to enhance the performance of the total performance of the functional performance of the product. And in the meantime, it can help to have some saving in cost, right? So we prepare a functional evaluation sheet, and also numerical evaluation sheet is prepared, that is converted to its numerical value by giving a scoring or something. For that, you can easily understand how each function is essential. And then we come up with the creative ideas, enter them in the creative worksheet and the creativity worksheet, and then selection of alternative through the decision metrics. Okay, number of creative ideas of them, we do select the alternative, right? And then finally we make the recommendation. Okay. Right. So see functional analysis. So the entire product is divided into number of sub-elements. Okay. Concrete flush valve, whatever the thickness body is there. And then there is a push button. Also there is a sleeve. Stopcock cup is there. And also piston is there. And also there is a spring. Also there is a washer, right? And you see this functional worksheet. You enter each function, why it is there, right? And so the first one, the valve, it is to hold and assembly. Okay, so it's hold it and connect it. Okay, and there is another one. So that is facilitate transfer, and it provides strength. Also, it indicates the working. Also, it's locate the piston rod, and it turns the stopcock cup. And so there are number of functions of that. And then also it facilitates tightening. So also provide grip, right? So this, this technical part of it, the people who has knowledge in this will understand, right? So right, so they will actually explain for the other team members of the technical part of it, and then others can do their suggestions and think of contributing to come up with creative ideas and its evaluation, right? So then you classify these once you have identified each function, identify whether they are basic or secondary, right? Some of these are basic functions, and then some others, many of the other functions are secondary functions, similar to what you see in what do you call this, pencil, right? There is yeah, so once identified, we can see what we are going to do with any functional element, right? Push button is there, sleeve is there, so whether we can go for any alternative for any of these sub-functional elements, okay? And for that, we go for numerical evaluation sheet. So weight. So we can give, in order to understand the functions of importance of each sub-function, we can go for a, again for that also we can go for a weighted scoring matrix, okay? So in terms of the cost, that we can easily get. So this is the weighted scoring. So here you can compare each of the sub-function in relation to others, okay? So take the A, the valve, and that can be compared with the rest of the other 6 functional elements and see how important it is, right? And compared to A is most important, so, or least important, whatever that ranking definition is not here. So A2, so means A is better, and compared to A and C, again A is better. Compared to A and D, D is better, but the degree of betterness is represented by this, the numbers 2, 3, 1, so on, right? And so you can see for the A, total it receives all the A's you need to add 2, 3, 5, and then 9. So it receives 14. Similarly, take the B. B, in the second row, you get B. There's no other places. Second row, the B receives 9, 10. C. Second row, there is a C2, and there are 3 C's. 9, 12, right? So that's the one given here, right? So that's 13 is there for the C. 9 to 11. There's 1, 2 missing. Yeah, sorry. A14, B10, C is wrong. How much? The D, there is 1, 2, so 3, and 9, 3, 12. That's correct. Okay, so you do this kind of a comparative weightage, and also that is represented, this is kind of a qualitative assessment. So you can take the actual cost of it. The total cost is there, and then you can see the valve cost. It's 60% or 61%. Push button is 16%. Sleeve is 12%. So like that, right? So in terms of the percentage cost, the valve becomes very expensive, and it contributes to nearly 61% of the total cost, right? And also the weightage is also received as the highest for the valve. Okay, right. So you put A is what? valve, yes. And then what is the most, C is what? Sleeve, it's 13. Yeah. Then D, stop clock. There's no, right. Okay. So we have done that evaluation of the functions, right? So we decide a push button found to be costly from the function cost matrix. Because so we didn't take the valve, flush valve. Why? It's a basic function, so we need not to, it is essential. So out of the secondary function, so you can see from this one, 16% is going to the push button, right? So the analysis is going to be for the push button, right? Whether we can do something with that. Okay. Costly from the function cost matrix. So creativity worksheet is prepared. So function turn stop cock cup. That is the so function, you can get it from the push button, right? Okay, the primary function is stop cock cup. And the alternatives, creative ideas: change the material to aluminium, change the material to aluminium alloy, material to plastic, materials to polypropylene, make it through forging, make the design simpler, make it in wood, make threads on the inner side, right? So these are some of the suggestions, creative suggestions, around 8. And so function stop cock cup. So there are 3 performance measures or criteria: cost, reliability, performance, right? B1, B2, B3, right? And these parameters are evaluated. B1, B2, B3. Cost is compared with the reliability and performance, and the score is 2. And then the reliability is compared with the performance, and the score is 1, right? And the performance, its score is 1. So total score is 4, right? The weightage of each objectives are B1 out of the 4, 2. B2, 1/4. B3, 1/4. So weightage of each. So cost is the most concerned criteria, right? So the alternatives, out of those 8, 3 is taken for further analysis. Use SAMAT, that is aluminium alloy. Use plastic, use polypropylene. Okay. C1, C2, C3. And the weightages are given like 0.5, 0.25, 0.25, right? For the 3 criteria, comparative scoring. Okay. And that gives 42 multiplied by 0.5, 84. 21.5. Porter, sorry, there's something wrong. There should be, so each of these B1, B2, B3, that needs to be, the ranking for that should be given, right?
Yes, there's something, or it has to be the other way, other side, upside down. So 84 into 0.5, it's 42. 86 into quarter, 21.5. Okay. Yeah, so when you take the total weightage, it should come as 84.75. 21.5 into 21.25, it's 75. And then 42, 21, 84.75. Yes. And similarly here also, adding the top score, 45, 18.25, 17.75. It should be like 35 and 45, yes, 81, right? So like that, we get the, so in the next step, what happens is, I hope you understand that. So don't worry about this number. So what we do is, now first we evaluate alternative criteria and so see how each of those criteria important, right? And so here the B1 is most important than B2 and B3, right? So the weightage reflect that, okay? And then we give a ranking of evaluating this each against this criteria, right? So that ranking comes at the bottom, and then this, we multiply this weightage by the rank, and we get the diagonal top score. And when you add the score on the top of the diagonal line, it gives the total value. And then based on the total value, we rank the options, right? So here, out of these, the first option, C1, that is use of aluminium alloy, is the most preferred alternatives, right? And then for the aluminium alloy, this one, cost improvement recommendation. So quantity per year is 8,000. So the push button is manufactured item. At present, it's made from brass. The material is costly, hence the cost of the part made out from it also costly. So it's recommended that the push button should be made in factory without changing the design of it through pressure die casting process. The proposed push button is to be made from CEMEC, an aluminium alloy, which is cheaper than brass, and with the use of PDC, pressure die casting process. The excessive cost of machine is also eliminated. Okay. So calculation of saving, you can see. The total cost saving incurred by per annum by the implementation of above recommendation is 280,000. Okay. So push button, the material cost, machine cost, planting cost 75. Push button with the aluminium alloy 2785. So this. Okay. So the difference per unit is 35. So earlier it was 75. Now it's only, if you go for aluminium alloy, it's just 40. So it comes 35 as saving. Okay. Right. So that is the thing. Okay. So very simple example. So if you can understand that this example, so the entire theory should be clear to you, right? Is that okay?
Last part was why, madam, 280,000?
It's per unit, 80,000. 8,000 is the demand, no? Potential saving. How much the 8,000 into 35?
Isn't it 280,000? Is that your question, no?
Yes, ma'am. Is it 8,000 by 35? Is it?
Should be.
Yeah.
I didn't calculate. So 8,000 is the the yearly requirement, no? 18 to 35 should be 280, no? Yes, that is the one. Per
Ah,
unit,
Okay, ma'am. Yes. Yes. Okay.
35 saving. So totally, okay, no? Any other question? I'll upload. I didn't go into Moodle. I'll upload the value management as well as life cycle cost. Okay, shall we stop for the day? 1:30, 1:40. You might have already gone for lunch, isn't it? Some of you.
No, madam.
Are you here? Okay. Okay.
Okay.
So
Thank you.
today I'll take 28, 27 attendance. Okay. 30. See, another 20 people never turn up now for the lectures, but you come to sit the exam. So obviously 20 students will receive fail marks. There's nothing to surprise. Okay. Yeah. Okay. I have never seen like all 50 turning for the lectures. So definitely that is,
Excuse me, madam.
yeah.
Madam, can we get the presentation today and last days to
Yeah,
Moodle?
that's what I said. I will definitely upload today. Okay.
Okay, madam.
Moodle is there, no? Yeah. Yeah, that's easy. Otherwise, I also forget. And then during the exam only, you ask for that. I don't know what I covered for. Okay. Okay, then see you next week. Enjoy your weekend.
Thank you.
Okay.